Okay. So we're just going to have a look at Gaussian elimination and row echelon form and reducing these and why matrices are used. So here's a nice simple simultaneous equation, and we're going to write it as a matrix. So 2, 3, 7, 1 minus 1, 1, and hopefully this one will come out fairly easily. This is what's called an augmented matrix. Just swap that. An augmented matrix because it's got the answers there basically. So what we want is a 0 here first. So I'm going to write it as R2 becomes 2 row 2 minus row 1. And what that's going to do, 2 lots of this is 2 minus 2 is 0. So we haven't touched the first row. It stays as 2, 3, 7. And this one becomes 2 lots of this is 2, 2 minus 2 lots of this is 2 minus 2 is 0. 2 lots of this is minus 2, minus 3 is minus 5. So you've just got to be a bit careful. 2 lots of this is 2, then minus the 7 gives you minus 5 as well. And then we can divide through this second line. So we can divide this by minus 5. And we get a 1 where we want. So 2, 3, 7. And this becomes 0, 1, 1 because we've divided through by minus 5. And then we can simplify that top line if we want. We could find the answer from here. We know that this means that y equals 1, 1y equals 1, and substitute it back in. So we know that 3y here would be 3, etc. But let's eliminate some stuff up the top. So now we're going to let row 1 equal row 1 minus 3 lots of row 2. So because there's a 0 here, it's nice for us. So row 1 is 2 minus 3 lots of 0 stays as 2. Row 1 minus 3 lots of this, so 3 minus 3 is 0. And 7 minus 3 is 4. And then this bottom line stays as that. We haven't touched that bottom line. And of course, to get it into reduced row echelon form, we can divide that top line by 2. So we get 1, 0, 2, 0, 1, 1, and that is a reduced row echelon form. Very simple matrix there, a 2 by 2 matrix. But that's really all we're doing, and we can read off the answers. X equals 2, Y equals 1. Thanks.